From a single spark to a roaring inferno, wildfires can consume thousands of acres in hours. But what exactly makes them start, and why do they spread so fast? All fires need three things: heat, fuel, and oxygen. Heat is needed to raise the fuel to its ignition temperature. Once ignited, that fuel will burn, producing enough heat to raise nearby fuel to its ignition temperature, and the cycle continues. And without oxygen, there'd be no combustion. Every fire triangle has these three: heat, fuel, and oxygen. Remove one and the fire dies. About 85% of wildfires are caused by humans, from unattended campfires, burning debris, or equipment sparks. The rest are mostly natural, often started by lightning in dry conditions. Lightning is thought to have ignited the 2020 Australian wildfires, which burned over 46 million acres. Fires spread faster uphill as heat rises and preheats vegetation above. Flames move in the direction of the wind, but wind also whips up the fire, carrying embers far ahead of the main body of the fire, starting spot fires kilometers away. Spot fires can become their own independent fires or merge with the original. Now, while extremely destructive, wildfires are a part of many ecosystems, clearing dead vegetation, returning nutrients to the soil, and helping some seeds germinate. In the American Northwest, for example, the 2020 fires helped some native plants thrive. Their seeds lay dormant in the soil for years, germinating only after a hot fire. Some animals also benefit. The intense heat of the fire creates open areas that small animals seek out as hiding spots from predators. In Canada, the frequency of forest fires has increased by almost 300% since the 1980s. In the western US, the area burned annually by wildfires has increased sevenfold since the 1990s, so it's clear that wildfires are becoming more common and more intense, largely due to climate change. Hotter, drier summers create conditions ripe for ignition and rapid spread. The risk is greatest in regions like California that have experienced extreme drought, and as climate change continues to cause hotter, drier conditions in many parts of the world, the wildfire season lasts longer and covers larger areas. This is not only in the western US. From 2001 to 2019, the global area burned by wildfires increased by 75%. By 2100, the global area burned could be up to 8 times greater than it is today. So what can we do? Well, understanding the science of fire helps us find solutions. We can learn how to best protect our homes and communities. We can clear vegetation around homes, making sure roofs are fire-resistant and have proper ventilation. Communities can also work together to create defensible spaces, large areas cleared of vegetation that can help stop or slow the spread of a fire. It might be tempting to see fire as purely destructive, but it's really both a force of destruction and renewal. Understanding the science of fire helps us appreciate its role in the ecosystem and in our lives. When you hear about wildfires raging across the globe, you might think only of the damage they inflict. But did you know that some ecosystems depend on fire to regenerate? And it's not just the obvious stuff like forests and grasslands. Even marine environments like kelp forests rely on fire to thrive.